Hi, in India, coal bed methane extraction process triggered a threat for millions of acres of agricultural lands, especially in Tamil Nadu region. Without considering the environmental effects of methane extraction under just a sheer commercial perspective, the government has given green signal for this deadly plan to the Great Eastern Energy Corporation Limited, GEECL, amid of serious protest by lakhs of people and farmers. This is a subsequent post regarding the issue about hydrofracking and gas extraction from farmlands. Please share this video across in your circle. I'm going to talk about hydrofracking or hydrofracturing in order to harness methane from methane hydrates. Hydrofracking or fracturing is a controversial oil and gas extraction technique developed in the late 1940s to gain access to fossil energy deposits previously inaccessible to drilling operations. The process, hydraulic fracturing, literally involves the smashing of rock with millions of gallons of water, along with sand and an undisclosed assortment of chemicals in order to bring gas to the surface. First, vertical wellbores are drilled thousands of feet into the earth through sediment layers, the water table, and shale rock formations in order to reach the oil and gas. The drilling is then angled horizontally, where a cement casing is installed and will serve as a conduit for the massive volume of water, fracking fluid, chemicals, and sand needed to fracture the rock and shale. In some cases, prior to the injection of fluids, small explosives are used to open up the bedrock. The fractures allow the gas and oil to be removed from the formerly impervious rock formations. Due to the multitude of potential health and environmental impacts of hydrofracking, source contamination can be complicated. The well location where drilling takes place is only one piece of the frac puzzle, since each well can require up to 8 million gallons of water and up to 40,000 gallons of chemicals. A well site may need up to 2,000 tanker truck trips. Per frac, a well can be fracked up to 20 times. Storage for the wastewater can take place either on-site in an injection well or in open-air ponds in the surrounding areas. Transport of the waste poses a contamination risk outside the actual well location. Air pollution also extends beyond the immediate drilling site and transportation route, since a byproduct of natural gas drilling is methane gas, one of the worst greenhouse gas pollutants contributing to climate change. Hydrofracturing causes huge air pollution. Methane is the main component of natural gas and is 25 times more potent in trapping heat in the atmosphere than carbon dioxide. A recent study by the National Oceanic and Atmospheric Administration monitoring gas wells in Well Country, Colorado, estimated that 4% of the methane produced by these wells is escaping into the atmosphere. NOAA scientists found the Well County gas wells to be equal to the carbon emissions of 1 to 3 million cars. A number of other air contaminants are released through the various drilling procedures, including construction and operation of the well site, transport of the materials and equipment, and disposal of the waste. Some of the pollutants released by drilling include benzene, toluene, xylene, and ethyl benzene, particulate matter and dust, ground level ozone or smog, nitrogen oxides, carbon monoxide, formaldehyde, and metal contained in diesel fuel combustion. With exposure to these pollutants known to cause short-term illness, cancer, organ damage, nervous system disorders, and birth defects, or even death. Chemical additives are used in the drilling mud, slurries, and fluids required for the fracking process. Each well produces millions of gallons of toxic fluid containing not only the added chemicals but other naturally occurring radioactive material, liquid hydrocarbons, brine water, and heavy metals. Fissures created by the fracking process can also create underground pathways for gases, chemicals, and radioactive material. Another scenario for contamination to occur is by faulty design or construction of the cement well casings, something that happened in the BP Gulf blowout disaster in 2009. Storage of the wastewater is currently under the regulatory jurisdiction of states, many of whom have weak to non-existent policies protecting the environment. Another side effect is earthquakes. Hydrofracturing can increase the risk of earthquakes. Earthquakes constitute another problem associated with deep well oil and gas drilling. Scientists refer to the earthquakes caused by the injection of fracking wastewater underground as induced seismic events. Although most of the earthquakes are small in magnitude, the strongest measured 5.2 on the Richter scale, the relationship with the storage of millions of gallons of toxic wastewater does little to ease the fears over fossil energy's long list of externalities. 2011 article in the journal Human and Ecological Risk Assessment examined the potential health impacts of oil and gas drilling in relation to the chemicals used during drilling, fracking, processing, and delivery of natural gas. The paper compiled a list of 632 chemicals identified from drilling operations throughout the United States. Their research found that 75% of the chemicals could affect the skin, eyes, and other sensory organs, and the respiratory and gastrointestinal systems. Approximately 40 to 50% could affect the brain nervous system, immune and cardiovascular systems, and the kidneys. 37% could affect the endocrine system, and 25% could cause cancer and mutations. Health impacts from fracking are only now being examined by health experts, since such large-scale drilling is a recent phenomenon. Exposure to toxic chemicals, even at low levels, can cause tremendous harm to humans. The endocrine system is sensitive to chemical exposures measuring in parts per billions or less. Nevertheless, many of the health risks from the toxins used during the fracking process do not express themselves immediately and require studies looking into long-term health benefits. So hydraulic fracturing is going to happen in Tamil Nadu, in many places like Neduvasal and Karaikal. And if it happens, it's going to trigger enormous amount of atmospheric pollution and also starting of earthquakes. Tamil Nadu is peaceful land without earthquakes, but methane extraction can start a new danger for Tamil people, that is earthquakes. So I think we need to stop 100% and ask the companies to go to northern regions where methane is available in billions of tons. They can go there and they don't have to take their machines at all. Just go empty-handed, go with a big tank, a small pipe, and just drill 10 feet and you get methane. Where is the need to drill 1 kilometer as you do in Tamil Nadu? It's a waste of energy. It is waste of resources. While enormous amount of resources available in the polar regions, Mother Nature is giving methane free of charge, and you can take any amount you want. You want $1 billion? Go to polar regions. You want tens and thousands of dollars? Go to polar regions. Polar regions is rich in resources, especially methane gas. That is the right place. People are not living there. There are no agricultural field. There are no poor people. Only some polar bears, some reindeer is living in polar regions. And you please take care of them and harness methane as much as you want. Happy collection of methane. Goodbye.